Alrighty, this is Horner again, and we're going to look at the 1D Kinematics multiple choice pretest number 21 through 30. This first one says the slope of a line connecting 2 points on a position versus time graph. So let's go ahead and do a really simple position versus time graph. Here's your position, here's your time, and if I have 2 points and I connect those 2 points with a line, oops, I really missed that. So let's just make my point bigger. There we go. If I connect the 2 points, remember the slope of the line is velocity, and that is just the change in position over the change in time. So that one is pretty simple. That is actually, now be careful because this is average velocity. Instant velocity would be any point on that line, but just the single point, not the average of the two. So here we really want to make sure that we have average velocity. We'll even do that. That'll help. Number 22. For number 22, it says which statement is correct about the relationship between the average speed and the magnitude of the average velocity for any motion. And the answer that you want here is letter B. The average speed is always greater than or equal to the magnitude of the average velocity. We've actually already seen this one before. If you remember, we had a circle and we said that if this is 1,000 meters, and we had a time of 100 seconds to go around that circle, then the average speed, let's do average velocity first, is equal to 0 because you start and end at the same spot. But our average speed would be equal to the distance, which is 1,000 meters divided by the time, and that would be 10 meters per second. So big difference there. If it's equal to, then we know that you're just going from one place to the other, and the distance and the displacement would be the same, which means that the speed from point A to point B would also be the same. For number 23, this one says the slope of a tangent line at a given time value on a position versus time graph. This would be its instantaneous velocity. So we're going to have position versus time, and we're assuming here that we have a curve. You could also have a straight line, but this makes more sense with the curve. If you know the slope of this tangent line, that would actually be the instant velocity. So this is the instant velocity at that point on the curve. For number 24, it says, what is the average velocity of an object when is it equal to that of instantaneous velocity? This is really only when velocity is constant. So if I have a position versus time, and I go like this, then the average velocity for along this line is the same as the instantaneous velocity. Same thing if I have a straight line going across, and this is velocity versus time. Here the instant velocity at any point will be equal to the average velocity for those. So either of those graphs would work. You just have to kind of make sure that this one equates to what you see here. For number 25, it says which statement is correct about the relationship between the instant speed and the magnitude, so that's just the number of the instantaneous velocity. And for number 25, the answer is letter B. The instantaneous speed is always equal to the magnitude of the instantaneous velocity. So if we draw a curve here for position versus time, the instantaneous speed at this point and the instantaneous velocity are the same because they are both the slope of the tangent line, and they're only at one point. They're not going to be different. So the instantaneous speed is always equal to the magnitude. And the reason they say magnitude is because if I draw it this way, then notice that it is decreasing. So my velocity is negative, but that is equal to the magnitude of the speed. So the slope is the same, it's just it's negative for velocity, but when we just look at the magnitude, we can ignore that positive or negative sign and just say it's equal to the speed. So those are the same. For number 26, this one says, suppose an object is moving with a constant velocity, make a statement concerning its acceleration. And for this one, um, the acceleration has to be equal to 0. So if it's moving with a constant velocity, so here we've got velocity versus time, and we can make that velocity constant and positive, constant and negative, or we could just make it 0. And for all of these, the acceleration is equal to 0 because there's no change in velocity. So no delta v. So therefore, there's no acceleration if we're looking at this moving with a constant velocity. It could not be going in a circle, because if it's going in a circle, maybe remember it's changing direction, and that would be a change in velocity. For number 27, at a given instant, the acceleration of a certain particle is 0. So we know that a is equal to 0. That also means that the velocity is not changing. So here we would have velocity versus time, and our velocity cannot change. It would be just a straight line. For position versus time, this would look like a straight line on the position versus time. So our velocity is constant, and therefore we don't have any acceleration at all. Next one is number 28, and for number 28, the slope of a line connecting 2 points on a velocity versus time graph. So let's go ahead and draw a velocity versus time graph. And if I have 2 points and I connect those 2 points with the line, we know that acceleration is the change in velocity. So here I have a change in velocity divided by a change in time. So that gives acceleration. For number 29, it says the slope of a tangent line at a given time value in a velocity versus time graph. So that would be this same thing that we just did before. If I have a tangent line on a velocity versus time graph, so let's actually make this one curvy. So if I have a curvy line for velocity versus time, and I draw a tangent line, that tangent line is really the change in velocity over the change in time, but this is the instant acceleration. If I look at the previous question, it said velocity versus time and 2 dots connecting the line. So this would be average acceleration. So there's a big difference between the two. Instant is at a point. Average is just the slope of the line for the velocity versus time graph. Here, this is not the slope of this curve. It's got many different slopes, but it is the slope of the tangent line. So be careful with it. And then finally, number 30 says, suppose an object is moving with constant acceleration. Which of the following is an accurate statement of its motion? And the only one here is in equal times, so it's letter B, equal times, your velocity changes by equal amounts. So if you think about the slope of a velocity versus time, you're changing the same amount each time, and that would be your acceleration. So acceleration is just the difference here for each one of these, or the slope of the actual line itself. And that is number 21 through number 30.